graph polynomial functions. So we're going to put it all together. All this stuff we've been learning about the graphs of polynomial functions. We're going to use end behavior, x-intercepts and multiplicity, the y-intercept and turning points to sketch the graph of a polynomial functions. Now, of course, we've got graphing calculators, but we're going to take a look at what we see and see if we can match our sketch to what we see in the graphing calculator without using our calculators. Sketching the graph, what do? Well, we determine the end behavior using the leading terms coefficient and degree. We find x-intercepts by setting the function equal to 0. We'll note each x-intercept's multiplicity because that tells us if it crosses the x-axis or if it touches and turns. We'll find the y-intercept by computing the value of the function when x is 0. And we'll use the fact that the maximum number of turning points is one less than the degree to check our sketch. Okay? So we'll do one example. This isn't overly complicated. We'll use our 4-step strategy above. We want to sketch this third degree polynomial, f of x equals x cubed minus 3x squared. So number 1, end behavior. Okay, our leading coefficient is plus x cubed. This tells us that the ends are opposite. It's an odd degree. We have opposite end behavior. It's positive. So this tells us it falls left and it rises right. Okay. We'll take a graph, and what do we know about the end behavior? There's our x-axis and our y-axis. It falls to the left and it rises to the right. That's good enough. Whoops, I missed you there. Sorry about that. There you go. It falls to the left and it rises to the right somewhere. I don't really know, but we'll put it there. Okay, 2, let's take a look at our x-intercepts. Where does it cross or touch the x-axis? This is when you have f of x is equal to 0. Okay, so we're going to set this equal to 0. X cubed minus 3x squared to get our zeros, which are also our x-intercepts. I can, whoops, I'm sorry, I'm forgetting all about you out there. I'm not getting my paper up high enough. There we go, x-intercepts. We're going to find the zeros, so I set it equal to 0. I have a common factor of x squared minus 3 equals 0. And let's see here. Take that back. I goofed up on that one. The common factor is x squared, and I'm left with x minus 3. That's much better, which means this is x times x minus 3 is equal to 0. So x is equal to 0 from this factor, or x is equal to 0 from this factor, or x is equal to 3 from this factor. So I have zeros at 0, and this one has multiplicity of 2, and I have a 0 at 3, and this one has multiplicity of 1. So at 0, it's going to touch and turn. At 3, it's going to cross. Let's raise this up, go to my picture. Okay, I know my end behavior does this and this somehow. I know I have a 0 at 0, and I have 1 at 3. And I know I'm crossing at 3. I'll bet it's going to go like this because it has to end up going that way. And I'm going to touch and turn at 0. Well, it makes no sense to touch and turn that way. I'll bet it touches and turns this way. What do you think? Probably makes sense. So that's my sketch. Let's get to another piece of paper here because I'm using space. Now let's find the y-intercept. So the third thing here is the y-intercept. And that is when x is equal to 0. What is the value of it? Okay, let me find my notes. So I want to know, what is f of 0? Well, f of 0, our function is, let's write our function down again since it's on the, since it's on the other page. Our function is f of x equals x cubed minus 3x squared. When is that equal to, what is it when x is 0? I get 0 cubed minus 3 times 0 squared, and that's 0. So I have a y-intercept at 0. Okay, so I'll go back to my graph. And what I had was an x-intercept at 3, which crossed and looks like this. I had end behavior kind of like this. I had an x-intercept here where it touched and went back. And it turns out that's also my y-intercept. So that's where my graph crosses the y-axis. So no change in my diagram at this point. And then let's see, number 4. Let's check our max turning points. Max turning points. We want to make sure we don't go over the maximum number of turning points. Well, degree 3 means I have 2 max turning points, 3 minus 1. So the maximum number of turning points is 2. And I can look up at my graph and I can see this is pretty good here. It looks like there's 1 turning point here. And it looks like it's going to come down and turn right here before it goes back up. So I can feel pretty certain that my graph is doing something like this. I'm not positive. This could go way down. I don't know. This could go up more sharply. This could go down more sharply. But that is the general idea of what's going to happen. Let's check it with our graphing calculator and see how we did. So go back into here. Y equals clear. Our function, our polynomial function was x cubed. Minus 3x squared. And I'll go to the standard window. And how do we do? Well, as you can see, according to my picture, this is a much sharper fall off and a much sharper rise than I had, and a little deeper than I went, but I have the basic picture, and that's what you do to kind of get a sense of what it looks like by hand.